Angel. Today we have really good expert. Allison Koenecke, I hope I pronounced your name correctly. Thank you. Allison is from Stanford. I guess you're almost done with your PhD.
Yes.
She's with Stanford, and before she was with MIT, she's really has this really good combination between AI, speech recognition, ML, and also fairness and social justice. This year with our events, we're focusing more on this because it's a hot topic and it's also what's going on in our society. Just this week, we have like raise in terms of anti-Asian hate crime. So it's happening almost every day. So an AI has been taking tour now, especially with kind of big players like Facebook and Google, where literally even their effort in terms of AI ethics is like not going well. So this is why we're kind of trying to get sense of what's going on. So this is why we invited Allison. The topic is automatic speech recognition, and you're doing it every day, whether through your smartphone, your banking, or translation and so forth. Allison said you can ask her questions, so you don't need to wait until the end. So feel free to ask your question in the chat box, or you can wait until the end, either way. So Allison, welcome.
Thank you so much. Thank you for that kind and super salient introduction. It's really great to be here with you all. And today I'll be talking, as you alluded to, about racial disparities in automated speech recognition systems. So, and also, of course, feel free to, you can ping questions in the chat or just interrupt me and unmute yourselves. Since it's a small group, I'm happy to keep this relatively casual. All right, so in terms of this talk, this is actually from a paper that is in PNAS, and I do want to highlight that this was done with a very interdisciplinary team, so across linguists and computer scientists and mathematicians, and without that kind of spread and diversity of the team that was doing this research, we would not have been able to produce this research. Okay, so with that, let's start talking about what does this title even mean? So what is automated speech recognition? So I'll be referring to this as ASR throughout this talk. And ASR systems you can think of as basically speech to text systems. So things like Alexa or Siri or Google Home. And the obvious question there is, well, maybe these sorts of things don't really matter. Why do we actually care if there's bias in these ASR systems? And in fact, there are quite far-reaching effects of these ASRs. So for example, there are applications for disabled individuals who use speech-to-text services in order to interact with web browsers, or in car systems. There are actually physical devices that doctors may use that are specifically trained on medical jargon that allow them to then transcribe patient notes. And of course, there are also things like court transcription services. And so, of course, the consequences of ASR technology may be biased if the underlying ASRs are biased, right? So for example, with court transcription services, what are the impacts downstream if these court transcriptions are only accurate for white defendants, but not Black defendants? So obviously this is a very important problem. And now let's turn to discussing how we audit different companies' ASR systems. So who are we auditing? Hopefully these 5 icons are familiar to you. And so we'll be evaluating these 5 different firms for their transcription services using their consumer-facing APIs that they each offer. And so to be clear, we aren't specifically looking at, say, Siri or Alexa, but rather the paid services offered by each of these firms that allow for batch transcription. So the idea is that we can take a bunch of audio WAV files or MP3 files, run them through each of these 5 services, and compare their performance. So let's take a step back and ask, though, is there any precedence for doing this sort of auditing work? And the answer is yes, in particular in the computer vision domain. So facial recognition was found to perform much worse for a woman with darker skin tones. And there have been lots of implications from this work, right? So in particular, the Black Lives Matter protests in 2020 led to Microsoft and IBM no longer selling these particular facial recognition technologies to police departments. Now, these sorts of studies, so this particular study and the one that I'll be talking about today, are relatively few and far between because you have to be a bit clever when auditing these companies because you can't often actually look under the hood and see exactly what these companies are doing, right? So the main thing we actually need in order to audit them are data, right? But a crucial thing is that our data need to be distinct from what data these 5 big tech companies are already using to train their models, because of course, if we just test on their training data, then we'll get perfect accuracy and this won't be a very useful study. So in particular, what data do we use? We're going to be using 2 different sources, Coral, which is where all of our Black speakers are derived from these interviews, and Voices of California, which is where our white speakers will come from. And these sources of audio data are from sociolinguistic interviews. So what are sociolinguistic interviews? This is effectively when one interviewer will ask kind of a standard panel of questions, and the interviewee will respond very naturally. So the questions might be like, oh, well, what games did you play when you were a child, or what did your parents do as an occupation, and things like that. But the interviewee's responses will be relatively fluid and conversational, and perhaps a paragraph. And so not so much a back and forth, but more of a relatively relevant but short question from the interviewer, and the interviewee speaks more. So what we end up being able to find is a lot of audio data from both white and Black speakers who are talking about relatively similar topics, but all in a very natural conversational way. And for context, for the computer science folks, this might seem like very small data because there are only 40 hours of interviews. For linguists, this is actually a lot of data. In fact, this is the largest study that involves the most amount of this sort of data that we've done to date in terms of running this sort of audio data through these ASR services. And crucially, these data sources that we selected all have human-generated ground truth. So what does this mean? It means that a linguist has gone through and tagged every single breath mark and word and laughter and every single type of thing that is uttered in the audio data has been transcribed and confirmed by a human. So this allows us to get some sort of ground truth that we can then compare to whatever the ASR generates, right? So now we have our data, and what do we do with it? Well, as I mentioned, we want to focus on the interviewee data because that is the natural conversation, and we want to focus on kind of natural flowing conversation as opposed to statements that are being read off a piece of paper, because those are not very similar to how a human might want to interact with an ASR. So we focus on interviewees speech only, and then we also split up each of these audio segments into 5 to 50 second long snippets that end at natural pauses. So basically one sentence or one phrase that someone says, it becomes its own audio snippet. And then across our Black and white speakers, we do some propensity matching. So we make sure that we have roughly matched samples across the ages and the genders and the number of seconds that the clip lasts for all of our Black and white speakers. So pictorially, it looks a bit like this. We have our Black and white audio snippets. They get fed into a black box system, so one of these 5 ASRs. And then for each snippet, out pops 5 different transcriptions from the 5 different services. And we want to compare these transcriptions to our idea of ground truth, so a human-generated transcript for each of the Black speakers and the white speakers. So the question there then is, well, how do you actually know whether these transcriptions are actually accurate? And so the way that we do this is with a metric called the word error rate, which is just the edit distance, right? And so it is the number of substitutions and deletions and insertions relative to the number of words overall. So for example, to go from the Google transcription of "that is a presentation" to the ground truth of "what a great presentation," you have to substitute that for "what," delete "is," and insert "great." So that's 3 changes out of 4 words in the ground truth. Now, how does this actually compare? So a word error rate that we calculated here of 75% is actually quite terrible. In fact, a word error rate of about 50% is already really unintelligible, because that would mean that every other word that you've transcribed is incorrect. And quick reminder, a high word error rate is bad, low word error rate is good. And I'll repeat this a few times because it is a bit confusing. But point being, a very high word error rate of 50% is already unintelligible. So what do we actually find in our data? Well, we see that, in fact, Black men in our sample have very high and very inaccurate word error rates from these ASRs. These ASRs are doing a terrible job of interpreting whatever they're saying. Meanwhile, for example, white women and white men are at about 20% word error rate, so doing much better. So what exactly does this sound like though? Because of course these are just numbers and it's hard to imagine what magnitude differences these are. I've pulled out a few examples for you to listen to. So firstly, let's listen to the average white man who has a word error rate roughly that of the average white man across the men in our sample, across the white men in our sample. And so you can see that the red markings are where the ASR system made an incorrect transcription. And so you can follow along and see if you think you could do better or worse than the ASR.
Well, when I was really young, I had a book of basketball statistics, and I would spend a lot of time reading them. And for some reason, I forget why now, but Jason Kidd ended up being my favorite player.
Okay, and in contrast now, let's listen to a sample of a Black woman speaking who has a word error rate roughly that of the average word error rates of all the Black women in our sample. So a higher and worse word error rate. And you can already see that there are many more instances of red markings here.
And she had these little like snow cone things. I don't even know what it was. But it's not like the snow cones up here. Like, I don't know how to explain it. But, you know, a bag of candy for a quarter, like a full bag of candy for a quarter.
All right, so did anyone find this particular snippet very hard to understand? I'm guessing the answer is no. You would likely be able to transcribe this better than the ASRs. And one more note I'll make now that you've kind of listened to and understand these word error rate magnitudes a bit more, is that these errors are consistent across firms, right? So we do see this roughly doubled word error rate, so twice as bad word error rates for Black speakers relative to white speakers across the board, across these firms. So now we have this high level view. We know that there's something going on here. Now there are going to be two main questions that I study in the rest of this talk. So first, we want to figure out, well, are these actual racial disparities? How do we know? And secondly, we explore more on the machine learning side. Well, what are the underlying machine learning mechanisms that lead to these sorts of disparities that we see? So first, let's start with how do we actually know that these are race-based? Okay, so first big thing I'll show you, these are the 5 cities from which we gathered our interviewees. And the first 3 cities, Princeville, North Carolina, DC, and Rochester, New York, these are where our Black speakers come from in the Coral dataset. And meanwhile, the Voices of California dataset, where we gather our white speakers, are from Sacramento and Humboldt. And so you'll notice that we do try to have a relatively even spread of, well, we have 2 rural locations and 3 urban locations. And so there is somewhat matching between the Black and white speakers, but of course, unfortunately, due to data constraints, because it is very difficult to conduct large-scale linguistic studies and do these interviews in the same location, we unfortunately don't have Black and white speakers who are interviewed who are from the same locations. So what we have to do then is think about, well, what if it's the case that the differences that we see in word error rate, where again, high word error rate is bad, low word error rate is good, maybe it's the case that these are simply because of location differences. So maybe it's just that the individuals who live in Rochester, in fact, are being understood fine, and the people who live in Princeville, because of their surroundings and the way that people speak in the local dialect, that is the thing that is driving these sorts of disparities. And in particular, one thing might kind of seem a little suspicious, especially if we're saying that this is a race-based issue, because our white speakers from Sacramento and our Black speakers from Rochester have very, very similar word error rates, right? So the question now is, well, how do we encode these differences in the different snippets that we hear, in particular across the Black speakers, because we see a really high variance across Black speakers. So in order to do this, we need to talk about AV. I'm going to take a quick side note on the language that we use to describe these languages. So I will be referring to African American Vernacular English as AV. There are, in fact, many different ways to refer to the study of the types of dialects that African Americans speak. For example, some people use African American language or African American English. And of course, the broader concept is we do not want to imply that all African Americans speak the same way across America. And so in this case, we maintain kind of the standards that are in the literature and refer to this as AV. So we would say that the African American individuals in our sample may speak AV. Meanwhile, in referring to how the white speakers in our sample speak, The standard linguistic term to use is standard English, quote unquote. Unfortunately, this is a pretty terrible term in that it kind of implies desirability, but in fact, the standard in standard English would actually refer to the regularization of these grammatical and other linguistic features. In any case, we do use the term quote unquote standard English to contrast with AV. So that is how I'll be discussing these different terms going forward, just so we're on the same page. Okay, so what we want to do now in terms of figuring out, well, what's going on in this chart is generate a new metric. So this metric is going to be called the dialect density measure, and it's based on the amount of African American Vernacular English, that is spoken across these different snippets. Now, why does AV matter? It's spoken by about 80 to 90% of the Black population. And so what we can do is we can hand count all of the different linguistic features that occur in a sample of snippets across these different locations. So what are these linguistic features? A few examples are listed here. They are both grammatical and phonological. So one example might be the zero copula, where in the quote unquote standard English formulation, you would say they are gone. But in the AV formulation, you would remove the copula, R, A-R-E, and instead say they gone. And of course, there are many other examples. We used about 50 or 60 different types of features that we would go through and manually tag. So this is just a few examples. And pertinently, AV features are more or less the same nationwide. So while you may have certain linguistic features particular to the location that you were raised or where you live, the fundamental features of AV, one might speak, would be roughly similar regardless of the location. And so again, what exactly do AV features sound like? Well, I'll let you listen to a few more examples. So here we see an example with very low word error rate, so high accuracy. And in this case, we already see there's high accuracy. There are very few red marks. And the one blue highlight is the one instance of an AV feature being spoken, which is syllable initial fricative stopping. And that's when V is going to be pronounced a bit more like D.
Grow older, we get darker. So I was extremely light when I was a child and very skinny. And so I was like an outcast because I was made fun of because I was the white girl at the school.
Okay, now in contrast to that, I'll let you listen to an example with many more AV features, and you can already see that this has much worse word error rate. There's many more red markings, and also, in fact, there are many more blue highlights as well, which are all different features of AV.
Well, my second grade teacher gave me the nickname Snake because she said I was sneaky, you know. I'd be sitting one place and she'd turn around, I'm sitting someplace else.
All right. And so maybe you can intuit where I'm going with this, but it seems like there is a clear correlation between the dialect density measure. So how many AV features are spoken against word error rate, where again, higher is worse. And so it does in fact seem to be the fact that where each dot is a different audio snippet, snippets that have a lot of AV features in them tend to be poorly transcribed by ASRs. And in fact, linking this back to our original question about the different locations, this is the exact same chart, but now I've colored in the dots. We see that Rochester, which was the location that had roughly comparable word error rate to our white speakers, in fact has very low dialect density measures across the board. So in general, in our sample, the individuals who were living in Rochester tended to speak with very few AV features, whereas individuals living in Princeville, for example, spoke with many more AV features in their speech. And so this is kind of our basis for thinking, well, in fact, this isn't so much location-based as it is AV-based. And of course, location will influence AV. It is very possible that because they live in these different places, that will affect the amount of AV features that they use in their speech. But at the end of the day, we do think that the main driver linguistically is the fact that individuals are speaking with more AV features or fewer AV features and less of whether it is a binary question of whether they are Black and white. Right, so the idea now is we're thinking about, instead of saying, well, why is it that ASRs perform poorly on Black speakers? It is in fact, why are ASRs performing poorly on AV speech, where AV speech is the sliding scale of, people can code switch. Sometimes people will use AV speech, sometimes they won't. Sometimes certain snippets will have AV features and other snippets will not. But in any case, the question is really, well, what do we do about this fundamental inability for ASRs to understand AV speech? And I'll do a brief interlude on geographic variation because that often comes up. In fact, there has been prior work on geographic variation. For example, Rachel Tatman had some work showing that Scottish and Southern accents in particular were quite bad. All of this prior work, however, was done on read speech as opposed to natural conversation. So for example, if you have a list of words and you just read them off that list, then that is where you find that sort of worse word error rate in those prior studies. So again, there hasn't been anything done yet with the type of study that we're doing at this large scale with natural conversation, but it seems quite likely that there would be additional geographic variation if you were to extend outside of these 5 cities, for example, especially for Scottish accents and Southern accents. One more note that I'll make that is in particular interesting about Southern accents is that AV speech and the particular linguistic features that we find in AV speech are actually quite similar to Southern accents in the US. And so there's a lot of transfer learning that can be done there, where if we improve ASR recognition abilities for AV speakers, that would likely improve recognition for Southern accents as well, and vice versa. And so there are lots of interesting commonalities there. Okay, so now we've more or less established, okay, well, we think that these are in fact AV feature-based disparities. So the next question is then, why do our ASRs yield these different racial disparities? And the first question to ask here is, well, how do you even know what's going on in an ASR? We obviously can't just go to Google or Microsoft or so on and ask them, you know, what are your machine learning models underlying these systems? Because of course that's proprietary and they won't tell us. But what we can do is we can guess based on the fact that modern ASRs tend to have 2 different parts. So the first part is the language model, and that deals with what you're saying. And so an example of this is GPT-2 or GPT-3, if you've been following the hype with OpenAI. These are things that predict words. Meanwhile, you have the acoustic model, which is the thing that basically thinks about how you're saying words. So these are things like intonation or inflection and phonology, and the acoustic models are also very critical to ASR. So ASRs are basically just language model plus acoustic model at a very basic level. So what we can do then is do a bunch of process of elimination tests to determine which of those underlying machine learning pieces are leading to the racial disparities that we see. So with that, let's start with the first test. So on lexicons. Now, let's envision a hypothetical world where all of the Black speakers in our sample have cats and love cats, and they talk about cats all the time, which is great. Meanwhile, all of the white speakers in our sample have dogs, talk about dogs all the time. That's also great. However, let's say that hypothetically, Google only knows about dogs. Google's never heard of a cat. Google has no idea what a cat is. And so anytime someone talks about a cat, Google transcribes that speech as dog. So what you can imagine would happen next is that dog is always correctly transcribed, cat is never correctly transcribed. And so you have this fundamental issue where you'll have biased word error rates because of the lexicon. So Google doesn't know that a cat exists, or any specific words that Black speakers tend to say more than white speakers exist, and that will lead to these disparities down the line. So it would be great to know if Google does in fact know all of the words that Black speakers in our sample are saying relative to white speakers in our sample. But the question again is, well, we can't just go to Google and ask, you know, please tell us every single word that you know, because again, that's proprietary and they won't tell us. But conveniently, recall that we had 40 hours of audio speech and we transcribed all of it through each of these 5 firms. So this means that we have a pretty large set of post-transcribed words that we know came out of Google. So we know that any word that Google has transcribed in the past must be a word that's in their vocabulary because they did manage to transcribe it. So what we can do is just take the union across all of the words that they've ever transcribed and say, okay, well, this must be Google's dictionary. At least they know all of these words. And so what we can do then is, now that we've approximately reconstructed these lexicons, these dictionaries for each of the 5 firms, we can then calculate the share of words that are in the ground truth. And what we in fact find is that about 99% of all of the words spoken by both Black and white speakers in our samples were covered by each of these 5 firms' dictionaries. And so in fact, the differences don't seem to show racial disparity. So it doesn't seem to be the case that lexicon is the driver of the racial disparities that we see. So next, let's talk about grammar. So how do we actually measure this? Well, to do this, we have to introduce another metric. So we're going to be talking about perplexity as this metric, and you can think about perplexity as a measure of confusion. So if you're very perplexed, you're very confused. If you have lower perplexity, you're less confused. So for this, let's pretend like you are GPT-3 or GPT-2, because at the time that we did the study, GPT-3 hadn't come out yet. But so let's pretend like you're a language model. You see the phrase, the dog jumped over the blank. And you think to yourself and you say, okay, I think there's a 5% chance the next word is fence, which is pretty high. And I think there's a 1% chance the next word is moon, which is pretty low. So then if you actually find out that the next word is fence, you say, oh, I'm not very surprised. I'm not very confused. I thought there was a pretty high chance that fence would be the next word. So I have a low perplexity. Meanwhile, if the next word is moon, then you might think to yourself, oh, I'm pretty confused. That doesn't make sense. I thought there was a very low chance that the next word was moon. So, you know, that is roughly what perplexity is referring to. Now, what we can do is calculate average perplexity for Black speech versus white speech under a few different public models, so things like GPT-2, and see what happens. So as a few examples, let's say, again, using the zero copula example, let's say we feed in the phrase, he is a pastor, into GPT-2. And the standard English, quote unquote, phrasing, he is a pastor, gives us a very low perplexity. So this model is not very confused by the phrasing, he is a pastor. However, the av phrasing, he a pastor without the apostrophe s, has a very high perplexity. So there's a lot of confusion when GPT-2, this language model, is presented with he a pastor. So what might we expect overall? Let's say that we run this across all of our actual samples, since these are just specific examples that we've pulled out manually. Across all of our speech, what do we find? In fact, we get the surprising opposite result. So in fact, we find that Black speakers have lower perplexity in the data than white speakers. So this means that language models are for some reason less confused about the formulations and the predictions of Black words going forward. And so why does this happen? Well, this is likely because the Black speakers in our sample uttered fewer unique words than the white speakers in our sample. And so as a quick example of this, let's say that I only ever say 4 words and Kareem only ever says 5 words. And so if instead of doing a fancy language model, you just guess uniform randomly about what my next word will be based on any of the words I've said in the past, then this very naive language model will guess my next word with a 1 in 4 chance, but guess Kareem's next word with a 1 in 5 chance, which is much lower. And so simply based on the number of words that tend to be in our vocabulary, this sort of guessing is a bit easier for language models. And so it seems like here we have found that, in fact, grammar is also not the big driver for the racial disparities that we see in word error rates. So now this leaves a final test to conduct, which is on phonology. So the main question here is, well, how do we get at whether the acoustic model is actually doing a good job of figuring out what the relevant words are? So what we can do then is remember that we used sociolinguistic interviews as our data. And so conveniently, as I mentioned before, this means the interviewers are asking kind of similar questions, which means that the interviewees are sometimes saying quite similar words. And so, for example, in response to an interviewer asking something like, oh, what did your parents do as their occupations? Multiple interviewees might say, oh, my father was a carpenter and my mother was a whatever, right? So what we can do is match pairs of these n-grams, these 5 to 8 word n-grams, and know that the ground truth is necessarily the same. So we know that the human transcribed ground truth is the same. And what we can do is look at whether the ASR transcribed transcripts are in fact better or worse based on word error rate relative to those same ground truths. And what we can do is then look across those 206 matched phrases and see what the different error rates look like. And hopefully this chart looks familiar to you because effectively we have managed to recover this doubled word error rate that we find for Black speakers relative to white speakers. And so it seems like the acoustic model, in fact, among the different machine learning models that are underlying the system are the culprit that lead to these sorts of disparities that we see. And so in quick summary of what we've found so far, effectively all of the ASR studies that we found showed roughly doubled word error rates for Black speakers relative to white speakers. And in particular, we do think that the poor ASR performance is due to the acoustic models being poor at understanding av speech and av vernacular in particular. And so what can we actually do with this? Well, first call to action is that more diverse data should be collected, right? So both of av speech and other non-standard varieties of English, so things like non-native speakers or Southern accents or Scottish accents. Secondly, this is not just a data problem, it's a human problem, right? So the speech recognition community does need to invest the resources to ensure that their systems and the institutions, right? So not just the people evaluating the systems at the end, but also the engineers and the product managers and so on from the genesis of a project are inclusive and thinking about these sorts of problems. It would be great if the ASR developers could do effectively what we just did using public data sets and regularly assess their improvement in diversity over time. And lastly, again, reaching back to the inspiration for this project, we should learn from other domains. So for example, with computer vision, right? And as I mentioned earlier, the gender shades paper found that facial recognition was biased and yielded poor accuracy for women with darker skin tones in computer vision. And how is that work borne out in real life? Well, the authors of that paper were able to directly interface with the government and big tech. And the end result, as I've already alluded to, is that firms that they audited agreed to at least pause selling their facial recognition technology. So the question there then is, well, what are the implications for speech-to-text technology, right? So is there something similar on the legal side with regard to speech-to-text and ASRs? So one example I'll point out is this idea of live captioning. So of course there's live captioning like that on YouTube where an ASR simply captions what you say as you're saying it. But there are also some companies that actually have a human in the loop. So as an example, let's say that you have a grandmother who is hard of hearing and uses this live captioning technology to receive a call from her granddaughter. So what happens is that whatever the granddaughter says in real time, there's an individual employed by this company who repeats back whatever this granddaughter is saying in standard English in a quiet background, no background noise, that sort of thing, fewer ums and uhs. And then that kind of sanitized human voice gets transcribed by an ASR, and that transcription, the written transcription, gets sent to the grandmother in real time so that the grandmother can understand what the granddaughter is saying visually. So how do we feel about this, right? Well, we know that services need to comply with the ADA, but we also know that companies are incentivized to replace humans with ASRs for cost-cutting reasons. But as hopefully I've shown over the past hour, ASRs are biased, right? And they also may produce lower quality transcriptions for different demographics of individuals. And so the question is this in violation of the ADA mandate? And I'll leave that open for you to discuss, but I'll just share one more example with you. So again, AB is really important to get correct in legal settings. So obviously, given that 12% of the US population speaks some degree of AB, we have to expect that AB will appear in some capacity in the courts. And I assume most people here have heard the lawyer dog story, but this quote basically summarizes it. Someone asks for a lawyer dog and it is grossly misinterpreted. And so given that we will necessarily have some number of defendants speaking AB, what is the best way to do court reporting, right? Again, cost cutting is relevant since some states are using ASR technology instead of or in addition to human court reporters. So again, we have this question of what could go wrong, right? And the key question, which I've quoted here, is how do we actually achieve fairness, right? So what do we think will result in the fairest trial for defendants? Well, as we already know, ASRs are biased. And a common example for why court reporters don't rely entirely on ASRs is that certain words are fairly commonly mistranscribed and they would totally invert the meaning of the transcription. So for example, now an OW might be transcribed as not an OT, and that's a serious error. But it's not necessarily clear that human transcribers are the catch-all solution. So there was a 2019 study, albeit on a very small sample of court reporters, which found that these human court reporters actually also consistently transcribed AB speech poorly. And so for context, in order to become a court reporter, you have to pass this particular test and you have to achieve a certain word error rate accuracy in your transcriptions. And most of this test presumably is done on quote unquote English speakers because it turns out that when you try to have them take the similar type of test, but on AB speakers, this benchmark of accuracy necessary to even hold this job was never achieved on AB speaking samples. And it's worth noting that this poor human transcription occurred for both white court reporters and for AB speaking court reporters. And so obviously this has important downstream impacts, right? So if you're consistently transcribing double negatives as a single negative, you're totally inverting this meaning. And so really the main takeaway here is that within many applications, and I've just kind of touched on the legal realm here, there's a lot of work left to do, especially on figuring out the right role for humans in the loop. And so kind of a big open question here, and shout out to Meredith Whitaker's Boston Globe piece a few months ago, is you do have this question of who should decide what the ground truth is. So recall that in our particular study, we base all of our calculations of word error rates and accuracy on a human-based ground truth transcription, but even humans are fallible. So really, what is the best way to go about this and how should we think about this? Very much still an open question and happy to discuss further. So with that, this is the end of my slides, but I'm happy to stay around and chat and answer questions. I will mention that if you go to fairspeech.stanford.edu, we do have some interactive kind of audio clips and visual charts that you can click on and kind of hear more examples similar to those that I showed throughout the slides. So feel free to do that or drop me a line.
Thank you, Allison. Very fascinating in terms of like, the evolution of this. Maybe I'll start and then I'll open down the debate. Have you seen a little improvement over the years in terms of the training data, like diversifying and being inclusive, or it's like flat?
So it's a great question. So I think first of all, it's quite easy and obvious to say that overall there has been a great improvement in speech to text, right? So if you're just thinking about, especially for quote unquote standard English speakers, a lot of these companies, right? So Google and Microsoft and so on, have users who are using voice recognition pretty regularly. And so what they can do is train increasingly more on their user data. And so it's quite easy for them to have this pipeline of individuals use our services. We then use their own data to train and make better models. And this works out great for the vast majority of users. But the critical issue here is that who are the people who are using, say, Google Homes or Alexa or Siri? These are people who are using this product because it works for them. So what ends up happening is that the vast majority of the training data that they're using from users are going to be standard English speaking and not people who are speaking AV or other variants of English, simply because that technology won't work for them. So why would they use it? And so in this way, you kind of get the snowball effect of, well, much more of their data is that for standard English, and their models are much more accurate for standard English speakers. But this isn't necessarily true for individuals who don't speak standard English. And I will say that in response to our research, many of these companies did reach out to us, and it seems like a subset of them are taking this seriously and thinking about how to improve and how to insert more diverse data into their pipelines. And so I think that's a positive step. And of course, the question remains to be seen to what extent they will be able to improve on this diversity front.
Okay, thank you. Do we have a question from the audience?
I have a question.
Yeah, go ahead, John.
Thank you for your for doing this work. I think it's really important. I was wondering if you have any solutions for how to detect. I'm sure there are many other groups, as you alluded to that in your talk, that might, have problems with this. How do you find those sidelined groups and get that information to the people who develop the products?
It's a great question. And I think at this point, for a lot of these tech companies, what they're driven by is revenue, right? So what they want to make sure is that large swaths of these different individuals aren't being missed from using their products. And so folks who speak AV, for example, as a large race block, 12, 13% of Americans, is kind of an obvious chunk for them to miss. And hopefully they will want to rectify their technology to incorporate this. I know that there are several other variants of English. So for example, Chicanx, or Yakima English, or other more regional varieties that are also facing struggles with ASR recognition, maybe don't have as much of a sway in terms of these companies because they make up a smaller share of their future users. But I hope that these companies will keep that in mind and also work on collecting diverse samples for them as well, because of course I think it's critical that they go out and do this sort of data collection. At the end of the day, a lot of the blocker on this is the step of data collection, because it is quite hard to do this correctly and then hire a linguistics grad student to go and transcribe everything by hand and that sort of thing. And so the time and money and effort put into the data collection step is really the main blocker. But if anything, these big tech companies relative to smaller startups are the ones who are well positioned to kind of take on that feat.
Yeah, go ahead.
I have a question.
Yeah, go ahead, Jonathan.
Okay, thank you. Allison, that was fascinating research. I have there's an ethical question that I found interesting here. You obviously need a set of data that has not been used as training data. So that, and you explained this at the beginning of your talk, so that you can audit these systems. But it strikes me, I mean, I'm not an expert, that data is exactly what we need these systems to be trained on. So how do you resolve this, that exactly the data that you need to audit these systems is the data that you need to train these systems? Have I got that wrong?
Sure. So I think the crux of that actually loops back to this question of data collection, right? So as of right now, the public data that I'm using, so for example, Coral data, which is a large corpus of Black audio speech, is kind of the biggest collection of interviews that are labeled and transcribed for Black speakers. But it doesn't have to be the only one, right? It simply happens to be the one that is public that I can use to do research, and one that we confirmed with these companies that they were not independently training on. And so I think it'd be great if, say, these 5 big tech companies end up training on that sort of data as well. That just means that for future benchmarking, we will need other sources of data and other sources, in particular of app speech, to basically evaluate these sorts of work. And again, this all kind of goes back to in kind of the optimal world, these big tech companies would go out and collect far more than just these 40 hours of speech that we highlighted because they happen to be publicly available. It likely makes sense for them to go out and actually collect far more than that, and sink in that time and effort.
In terms of federal regulation, in terms of ASR, what things you think the federal government should do?
So,
go ahead.
I mean, it's a great open question. And of course, caveat, I'm not sure that I have full information on what these companies are doing on the back end legally, and I don't have full information on what the government necessarily thinks is right. I will say that I think it's a bit scary to regulate and say, oh, you must achieve this word error rate on average for each separate demographic, because one concerning point, for example, is that for startups, for example, who don't have the resources to put into collecting all sorts of diverse data, that would be a huge barrier to entry. So that's more on the kind of industrial organization competition side for these firms. But otherwise, I think it does make sense to ensure that you do have sort of demographic parity along some sort of line, if not word error rate, then kind of some broader form of usability or paraphrase error rate, which measures more of the understanding as opposed to the specific words. So I think there's a lot to be explored there, especially on the legal side. I'm happy to hear if you have any other thoughts on this.
I'm thinking like in terms of disability, for instance, like for services that they should be compliant, like automatic captioning. It should be regulated, so service provider need to offer that and use heavily ASR.
Mm-hmm. Yeah, so broadly, I think regulating somehow would be good. The question is who regulates, right? And so in particular, the main source of regulation, I think, that speech to text currently falls under is primarily with the ADA, which is kind of funny because I think on average when an abled person tends to think about speech to text, you don't seem to think about, oh, well, what legally would this be under? You might think, oh, maybe the FCC or something. But in fact, it actually is probably most relevant to the ADA, which I think is a bit counterintuitive, but potentially for the best in that these are the folks who do want to ensure, lack of discrimination across the board.
By the way, changing topic, maybe it's out of scope here. In terms of machine translation, is this will increase if you move to kind of another language to increase accessibility? Like that corpus, and you run into like another word, like WER for another language?
Right, so that was actually part of the inspiration for our work, because in fact, when you do sort of not machine translation, but if you just look at ASRs, they work quite well in French. And so you have this fundamental question of, well, ASRs work pretty well in standard English. ASRs work very well in French. French is very far from English. Av speech is English, but slightly different. And so why are you getting such worse word error rates on Av-based English as opposed to standard English when you know that you can do well on French? So that's actually part of the inspiration for this, is that you know that there are some aspects of ASRs with other languages that are doing quite well, in fact. And so what are the relevant concerns there? And yes, I am looking at Jonathan's chat, and I am sure there is a lot of difficulty measuring and picking up on the different Chinese dialects. So that it also remains an open question. We only looked at English, but I'm sure that you could find kind of comparable concerns across the world.
In terms of military applications.
So that I'm not super privy to, but I can imagine you would face similar issues where if, for example, someone using these technologies were not a standard English speaker, there could be dire consequences.
Any other question from the audience?
I just wanted to thank you for focusing on the data. I think that many people, when they think about these systems, they focus highly on the algorithm and the model of the languages being used, but in these times, the models are, developed by the machine based on the data. So that's so important. And I also think it's important, as you did, to focus on the need for the human intervention at various important places when we're trying to, to work through these systems and draw conclusions from what the machine is telling us. So again, thanks for focusing on those things. I think they're important too.
Thank you. And I'm glad that my takeaways were very clear. So sounds like we're all on the same page here.
Okay. If no more question. Thank you, Allison. Thank you very much. We enjoyed the talk.
Thanks so much for having me.
Okay. Bye, everyone.
Bye.